Hey everyone, in this one we're going to take a look at how to simplify a radical expression that involves variables. Alright, here it is. Okay, so in order to simplify a radical expression that looks like this, that has some variables involved, we're going to take advantage of the fact that radicals do not, while they may not distribute across addition, they do distribute across multiplications. What I mean by that is if I take the square root of something plus something else, then that does not equal the square root of the first thing plus the square root of the second thing. So we say that that radical is not going to be able to distribute across addition. But when we have a product underneath the radical, so instead of a sum underneath the radical, we have a product. We have all multiplication here. This means 49 times x squared, and we have the square root of all of that stuff. Then we can distribute that radical to the two factors. So I can say the square root of 49x squared is equal to the square root of 49 times the square root of the x squared. And so then we know the square root of 49 is 7. We know the square root of x squared is x. And so we can end up just multiplying these two things together, and we get 7x. All right, so this fact here is what we're going to be using to handle these. So just like we just did, since this is all multiplication here, this is 108 times x squared times y to the 6th, I can now break this up into the square root of 108 times the square root of x squared times the square root of y to the 6th. And then I can just simplify all of these parts and then multiply them all together. And so if you remember how to express this one here in simplest radical form, you find the largest perfect square that goes into 108, and that would be 36. So this is going to simplify to the square root of 36 times the square root of 3, and then the square root of 36 is just 6. And then we know the square root of x squared is x, and we know that the square root of y to the 6th is going to be y to the 3rd, because y to the 3rd times y to the 3rd is y to the 6th. Okay, and now I have all of my parts here that I can just multiply together. And so how this is going to work is all of the parts that don't have a radical, I'm going to put out front. So 6xy to the 3rd will be out front, and then any parts that do have a radical, I will put underneath a radical. And so this here would be what we call simplest radical form of this expression. Okay, so we'll do a few more examples here to cover some different scenarios you might find yourself in. Now here we have something that's already out in front, and that's fine. We don't have to do anything with that yet. So we're going to rewrite this expression as 2x and then times the square root of 48 times the square root of x times the square root of y to the 8th. Okay? And now the 2x doesn't have a radical on top of this, so I don't need to do anything with that. So I'll just leave this 2x. The square root of 48 we can break down into the square root of 16 times the square root of 3. And the square root of 16 is, of course, 4. Now, the square root of x, we're just going to leave that as is, because that's as simplified as we can get. So I'll leave that as the square root of x. And then here, we're going to think about what times itself would give us y to the 8th, and that would be y to the 4th. Okay, so now we have all of our parts, all of our factors. And again, anything that's not underneath a radical, we're going to pull out front. So I have a 2x, a 4, and a y to the 4th. So 2x times 4 would be 8x. and then I have a y to the fourth. All right, and now we have two things with radicals above them, so I'm going to put them both underneath the radical. So 3 times x is 3x. Okay. Now, this one down here is a little bit tricky. So we have the 10x out in front, which is fine. We don't have to do anything with that yet. But here, notice that we have the square root of x to the 5th. Now, that's a little bit different than something like the square root of y to the 8th, where we know we can just cut that exponent in half and get the y to the 4th. We don't really know what the square root of x to the 5th is, at least not cleanly. And so I'm actually going to break down the square root of x to the 5th to the square root of x to the 4th times the square root of x, because x to the 4th times x gives me x to the 5th. So I can factor the square root of x to the 5th into the square root of x to the 4th times the square root of x. And now what this allows me to do is I can actually take the square root of x to the 4th. I know that's x squared. Okay? And so now I have my 10x times x squared, which is going to be 10x to the 3rd, and then I just have a single x left underneath the radical there. All right, I'll do one more. So similar situation here. I'm going to rewrite this as 2 times the square root of 18 times the square root of x to the 3rd times the square root of y to the 7th. All right, the 2 I'm not going to do anything with, so I'll leave that as 2. The square root of 18 I know is the square root of 9 times the square root of 3, and the square root of 2, not 3, and the square root of 9 is just 3. Okay, now here I don't know what the square root of x to the 3rd is, but I can break this down into the square root of x squared times the square root of x, and I know that the square root of x squared is just x. Okay, and then similarly for my y to the 7th, I can break that down into the square root of y to the 6th and the square root of y. And I know the square root of y to the 6th is y to the 3rd. All right, so I have a lot of parts here. So you want to be very careful. I have a 2 times 3, which is 6, times x times y to the 3rd. And now everything else that's under radical, I have a 2, an x, and a y. So times the square root of 2xy. All right, so this here would be the simplified radical expression of this one here. All right, so in another video I'll cover the same concept but for cube roots instead of square roots. It's a very similar process, but you just have to basically divide all of your exponents by 3 instead of by 2. All right, and with that said, guys, it's been demonstrated.